Dear students, welcome to my channel BK Bio's Essence of Medical Biochemistry. In my last video, I have told you about the physical properties of carbohydrate and I have told you in detail about the various types of isomerism exhibited by monosaccharides. Today we are going to discuss about the chemical properties. So we'll see what are the chemical properties of carbohydrates. First is oxidation. Next is reduction. Third property is the reducing property. So please remember, reduction and reducing property, they are not the same, they are different. Next is dehydration. Next property is formation of ozazones. The reaction with the phenylhydrazine, it gives corresponding ozazones. Next property is formation of esters. And then we are going to learn about glycosides. So what is a glycosidic bond? What are the physiologically important glycosides? All these things we are going to cover under glycosides. So these are the properties: oxidation, reduction, reducing property, dehydration, ozazone formation, formation of esters and glycosides. So we'll see one by one in detail. Now let us learn the various chemical properties in detail. First chemical property is oxidation. So what is oxidation? Oxidation is addition of oxygen or removal of hydrogen. Under mild oxidizing agents such as hypobromous acid, the functional group is oxidized and it gives corresponding aldonic acid. So I have written the structure of glucose here. So this functional group is oxidized and it forms gluconic acid. So it is going to give corresponding aldonic acid. For example, glucose gives gluconic acid. Mannose gives mannonic acid. Galactose gives galactonic acid. So it gives corresponding aldonic acid. Now if the functional group is protected and the end carbon, if it is oxidized, you are going to get corresponding uronic acid. So end carbon, if it is oxidized, you are going to get corresponding uronic acid. For example, glucose gives glucuronic acid. Mannose gives mannuronic acid. Galactose gives galacturonic acid. So it gives corresponding uronic acid. So what is the importance of uronic acid? Conjugation reaction. Okay, so to make water soluble, glucuronic, mannuronic, galacturonic. So conjugation reaction, that is the importance of uronic acid. So this we will be studying in detail in detoxification. Now if both carbon, that is the functional carbon at the and the terminal carbon, if it is oxidized under strong oxidizing agents such as concentrated nitric acid, you are going to get corresponding saccharic acid. So this is glucosaccharic acid. So if glucose is oxidized, you are going to get glucosaccharic acid. Mannose, if it is oxidized, you are going to get mannaric acid. And galactose, if it is oxidized, that is the first carbon as well as the N carbon, galactose, if it is oxidized, you are going to get mucic acid. So formation of mucic acid, this test is an important test for the identification of galactose. So hope you understood about oxidation. So if the first carbon, that is the functional group, if it is oxidized, you are going to get corresponding aldonic acid. Nth carbon, if it is oxidized, you are going to get corresponding uronic acid. If both carbon, that is the functional carbon as well as the N carbon, if it is oxidized, you are going to get corresponding saccharic acid. Coming to the next chemical property, that is reduction. When treated with a reducing agent such as sodium amalgam, the aldehyde or keto group of monosaccharides undergo reduction to give corresponding hexahydroxy alcohol. For example, so this is glucose. It gives corresponding hexahydroxy alcohol. Why it is hexahydroxy alcohol? 1, 2, 3, 4, 5, 6. 6 hydroxyl group. So glucose undergo reduction to give corresponding hexahydroxy alcohol, that is called as sorbitol. Mannose undergo reduction to give mannitol. Galactose undergo reduction to give dulcitol. Fructose undergo reduction to give sorbitol plus mannitol. So it gives corresponding hexahydroxy alcohol. Now we should know Now we should know the clinical significance of sorbitol, dulcitol, etc. Sorbitol, sorbitol and dulcitol due to osmotic effect causes swelling of cells. So this is responsible for formation of cataract. Diabetic retinopathy is due to the accumulation of sorbitol. Galactosemia, congenital cataract is due to the accumulation of dulcitol. Mannitol is used to reduce the intracranial tension. So mannitol is used to reduce the intracranial tension by forced diuresis. Coming to the next chemical property, that is reducing property. Now the reducing property of a sugar is attributed to the presence of free functional group, that is free aldehyde or keto group present in the anomeric carbon. So reducing sugars in mild alkaline condition undergo tautomerization. Tautomerization means shifting of hydrogen to form enediol. So I will show you what is enediol means. So the hydrogen is shifted here. Okay. So you might have studied alkane, alkene, alkyne like that. So double bond, that is ene, presence of two hydroxyl group. That is why we call it as enediol. So glucose under mild alkaline condition will be converted to fructose and mannose through the formation of common enediol. Okay, this reaction is called as Lowry-de Bruijn van Eckenstein transformation. So Lowry-de Bruijn van Eckenstein transformation. So the principle of Benedict's test is based on this reducing property. This I will be explaining later in detail when I take the practical aspects. So hope you understood about reducing property. Coming to the next chemical property, that is dehydration. So what is dehydration? Dehydration means removal of water molecule. Carbohydrates undergo dehydration when treated with concentrated sulfuric acid. These carbohydrates undergo dehydration to form furfural. So what is furfural? Furfural is a heterocyclic compound. For example, glucose undergo dehydration in presence of concentrated sulfuric acid. 3 molecules of water is removed to form hydroxymethyl furfural. So this is called as hydroxymethyl furfural. So this is hydroxymethyl furfural. This will combine with the phenolic compounds, for example alpha naphthol, to form colored compounds. This is the basic principle for a test called as Molish test. So this Molish test principle also I will be explaining later in detail in practical aspects. So you should remember that carbohydrates undergo dehydration to form furfural. Coming to the next chemical property, that is formation of esters. So what is an ester? When an alcohol combines with an acid, we will get an ester. So esterification of carbohydrate can take place enzymatically as well as non-enzymatically. Generally, carbohydrates combines with the phosphoric acid in metabolism. For example, the phosphorylation of glucose, body metabolism starts with the phosphorylation of glucose. Might have studied about glycolysis. So it can form glucose 6 phosphate, glucose 1 phosphate, etc. Okay, so esterification means when an alcohol combines with an acid, it forms ester. Coming to the next chemical property, that is formation of ozazones. So all reducing sugars reacts with the phenylhydrazine to form corresponding ozazones. So I will show you. For example, glucose. This is phenylhydrazine. Okay, so this phenylhydrazine is added. A molecule of water is eliminated. So first it forms hydrazone. It reacts with one more molecule of phenylhydrazine. And it gives corresponding osazone. Okay, so this is osazone. Since it is glucose, we call it as glucosazone. Fructose means fructosazone. Glucose and fructose differ in their structure in the first two carbon atom. Okay, and this difference is masked by the addition of phenylhydrazine. Okay, that's why glucose and fructose gives same osazone crystals. It gives long needle shaped. Glucose and fructose gives long needle shaped osazone crystal because glucose and fructose differ in their structure in the first two carbon atom, and this difference is masked by the addition of phenylhydrazine. Maltose gives sunflower shaped osazone crystal, and lactose gives hedgehog shaped osazone crystals. So all these osazones again I will be explaining when I take the practical aspects of carbohydrates. So now you just understand that carbohydrates, this reacts with the reducing sugars, react with the phenylhydrazine to give corresponding ozazones. Why glucose and fructose give same ozazone? Because glucose and fructose differ in their structure in the first two carbon atom, and that difference is masked by the addition of phenylhydrazine. Coming to the next chemical property, that is glycosides. So we should know what is glycosides. So glycosides are formed when hemiacetal or hemiketal group of one carbohydrate reacts with the hydroxyl group of another carbohydrate or a non-carbohydrate. So if it is a non-carbohydrate, we call it as aglycon. Aglycon. So when hemiacetal or hemiketal group of one carbohydrate reacts with a hydroxyl group of another carbohydrate or a non-carbohydrate, glycosidic bonds are formed. So I will show you one example for a glycosidic bond. So it can be formed between two carbohydrates or it can be formed between a carbohydrate and a non-carbohydrate. So this is the structure of glucose I have written. So this is alpha D glucose. Okay, again I am drawing the structure of alpha D glucose. Okay, so now you see here bond is formed like this. So how we can name this? This is one alpha D glucose. This is another alpha D glucose. So we can call it as alpha D glucosyl. The bond is formed between the first carbon. See, this is hemiacetal. Okay, the hemiacetal group of one carbohydrate reacts with the hydroxyl group of another carbohydrate. So fourth carbon. You can see here hydroxyl group of another carbohydrate. Okay, so we call it as alpha D glucosyl 1,4 alpha D glucose. This is nothing but a structure of maltose, just to show how a glycosidic bond is formed. So now I will give example for physiologically important glycosides. So I told you a glycosidic bond can be formed between a carbohydrate and another carbohydrate or a carbohydrate and a non-carbohydrate. See here, example, glucose is a carbohydrate. Okay, this is a non-carbohydrate molecule, fluoratine. It forms fluorescein, that is the physiologically important glycoside, produces renal damage in experimental animals. Galactose is a carbohydrate, combines with the aglycon, that is the non-carbohydrate molecule, that is digitogenin. It forms digitonin, which is used as a cardiac stimulant. So with this we come to an end to the chemical properties. So hope you understood the chemical properties. So if you like my channel, please subscribe my channel, share, and please give your valuable suggestions and comments so that I can improve myself. and we'll see you in the next video with explanation about disaccharides. Thank you.